Now we take up this problem number 37 of your textbooks. Let's see what this problem says. There is a diagram given. The diagram is very clear. There is a big pulley and this is a big pulley and there is a small pulley. There is a small mass. It appears from the diagram that the big pulley will try to go down and which will pull the small mass towards right. Now, the problem says the descending pulley. That means it is already mentioned that this pulley is descending. Okay. Shown in the figure has a radius of 20 centimeter and a moment of inertia of 0.2 kg meter square. That means this is a heavy pulley. This is a part of the system. So its radius, it says, is 20 centimeters. That means 0.2 meter. And the moment of inertia is also given, is also 0.2. The fixed pulley is light. That means this pulley is light. It's not a part of the system. It's just roll and the string rolls over it. And the horizontal plane is frictionless. So this plane is frictionless. That is good. Friction is gone. Find the acceleration of the block. This is the block. If its mass is 1 kg. So this mass is 1 kg. This is a small mass and it has got an acceleration towards right. Of course, it will have an acceleration towards right. Let's say this acceleration is A. This is the question. What is the acceleration A? Acceleration is how much? This is the question. Now, let's start solving this problem. What do we have to find? We have to take the small mass and the pulley one by one. Now, from your knowledge of kinematics, the earlier chapters, if this acceleration is A, obviously this acceleration will be A upon 2. Because there are the rope goes round, there are the total motion of this string A is double the motion of this big wheel A by big wheel here. And let's say this, we can consider this mass is capital M. This mass capital M, of course, can be found out from the relation of radius and moment of inertia. Now, to solve this problem, let's first consider the one thing more. Let us consider this tension is T1. This tension is also T1 because this small pulley is frictionless and it's a very light pulley. So the tension on the string on both sides is same. This tension, of course, will be different. This will be T2. Let's say this is T2. Now, considering the free body diagram of the small mass, I can write it this way. Considering the free body diagram of the small block, the free body diagram of the small block, what do you find? Its tension is T1, which produces an acceleration of A on a mass of 1 kg. So here, T1 is equal to MA. M is given to me 1 is A. So therefore, we write T1 is equal to A. This is one equation. This is one equation. Say this is equation 1. Now consider the rotation of the big wheel. Next we consider the rotation of the big wheel. Consider rotation of the big pulley. Consider rotation of the weak pulley. What do you find? The pulley, of course, will rotate in this direction. You know, which is moving in which direction, that perception has to be clear to all students. If you make a mistake in that, then whole thing will be wrong. Because the small mass is coming towards right, so obviously the pulley will move anti-clockwise. Now, what is the anti-clockwise torque? Anti-clockwise torque. Anti-clockwise torque is equal to T2, because T2 tension is rotating it anti-clockwise. Anti-clockwise is T2R minus T1R. This is anti-clockwise torque. This is equal to T2 minus T1R. This is the anti-clockwise torque. This has to be equal to I alpha. I alpha. If it is angular acceleration is alpha. Now this I alpha is I into alpha is tangential acceleration divided by R. Now its tangential, acceleration is A by 2. A by 2 divided by R. So this is actually equal to IA by 2R. So from this equation, what do we get? We had T2 minus T1R equal to IA by 2R. So what we finally get, T2 minus T1 is equal to 2A by 2R square. Sorry, this is not 2, this is I. Be very careful. This is I. This is not 2. This is IA by 2R. Now, I and R, both values are given. I is 0.2. I is 0.2 multiplied by A divided by 2 multiplied by R is also 0.2. So this is 0.2 whole square. This is equal to, this is 0.2A divided by 2 into 0.04. This is equal to, if you multiply numerator and denominator both by 100, this is equal to 20A by 2 into 4. So this is equal to 5A upon 2. So T2 minus T1 is 5A upon 2. Write it once again, because we will be using it as an equation. Therefore, T2 minus T1 is equal to 5A upon 2. Next, we'll go to another consideration. Now we consider, well, before coming to that, we have got here T1 is equal to A, and we have got here T2 minus T1 is 5A by 2. So from here, we can find out the value of T2. So T2 is equal to T1 plus 5A by 2. The value of T1, we have already got A plus 5A by 2. This is equal to 7A by 2. This is one relation. Let us call this relation 3. Well, next is, let's find out some space here for you. Right. This we have got here. Next we go here that here we have got the value of T2. Now we consider the free body diagram of the wheel. Consider free body diagram of the big pulley for its downward motion. Downward. If you do consider that, then what do you find? Its downward force is capital Mg. Minus, there are two upward forces. One is T1 minus T2. So Mg minus T1 minus T2 is the net downward force, which causes an acceleration of A by 2 on a mass capital M. Right? So from here we get capital Mg minus, we have already got the values of both T1 and T2. T1 is A, T2 is 7A by 2. This is equal to capital M A by 2. Right? From there we get Mg minus, now this small a plus 7A by 2 is 9A by 2. 9A by 2 is equal to capital M A by 2. So we get, therefore, Mg is equal to capital M plus 9 by 2A. Capital M plus 9 by 2A. From here we get A is equal to 2 mg. So A is equal to 2 mg divided by capital M plus 9. Mg divided by capital M plus 9. So this is the value of A. Now, this is the value of A they want us to find out. Now, we can always calculate the value of M because for this wheel, the radius and moment of inertia are both given. So obviously, we can find out A. For the wheel, so let us write like this. For the wheel, for the big pulley, for the big pulley, we know I is equal to m r square by 2. This is known whenever a pulley rotates around an axis passing through its center, its moment of inertia is m r square by 2. From there we get m is equal to 2I by r square. 2I by r square. Now both I and r is given. 2 into I is given 0.2. R is given also 0.2 whole square. So this, then you have 2 divided by 0.2 is equal to 10 kg. So mass of this wheel is known, it is found at 10 kg. If the mass of this wheel is known at 10 kg, then from this relation, we can find out the acceleration A. So we go this way. So A is equal to 2 multiplied by capital M is 10 kg, G is 9.8 divided by capital M is 10 kg plus 10 kg plus 9, M plus 9. M plus 9. If you calculate this, this will be something like 10 meter per second square. This is the value of A, right? So this is how to solve this problem. Now we go to the next problem now.